continuing our discussion of final exam multiple choice from our study guides. We're going to have to do closest to the delta H of the reaction for the following halogenation. So what bonds are being broken? Watch out for this first one. It's a lot like the one we had on our test where nobody got the right product. I mean, nobody. Yeah. Okay, so I hope you agree that there's an H here, right here, and there's not an H on the same carbon here. That's the H that's got to go. I know you're saying, why doesn't the iodine end up there? Well, the answer is pretty simple. Once that's gone, it's a radical, and the reason that allylic radicals are special in the first place is the R word. Yes, they resonate. There you go. That looks like an arrow, that last one. Don't like it. Resonate, resonate, resonate. And that makes this, and resonance cannot be stopped, everybody. It's happening whether you like it or not, if it can happen. Double bond here, radical there. And the key is, when you make this bond here, it's a secondary allylic. And if you made the bond to the tertiary allylic, it's not as exothermic. It's got a less negative number. I'll prove it. If I made the bond to iodine on the tertiary allylic, I'm going to get this number here. Tertiary allylic, negative 165. Why is it negative? Because you're making it. Secondary allylic, negative 169. That's more exothermic. It's faster. You will make more secondary allylic than tertiary. And you didn't even need to know that for this question because I told you the product. It's not like you had to figure it out. So we don't need the negative 165. We need the negative 169. Negative 169. This one I've used so many times. I've memorized it, but you know, you look it up. It's on the same table. Negative 431. I don't know why I drew an I here. That should be an H. That's what you're breaking, right? Tertiary allylic C bonded to H needs to be broken. That's this one, positive 354. Positive 354. ICL needs to be broken. Way down here, CLI positive 211. And if you're like me and I don't have a calculator, I'm going to do the adds. The two on the left add up to 565. And the two on the right add up to negative 600. Interesting. Having trouble with that? 169, 431. Just add up the positives and the answer's got the wrong sign, right? 0, carry the 1, 9 gets to 0, carry the 1, and that's 6. There you go. And everything's supposed to be minus, 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 minus. And that's negative 35. And that's this one right here. And it didn't even break it down to prop 1 and prop 2. This is just the overall reaction, wasn't it? So look for one just like that. I'm not messing with it. I'm just going to change the molecule. I'll cut it down to 6 answers. And it's overall reaction. I won't do prop 1, prop 2. I'll do it like I did here. And then different reaction for SN2. You got to remember SN2, that's the one where the nucleophile does a backside attack on CX, right? And that's it. The reaction's over. One step. So get rid of the reactions that have 2 steps. You got two hills is 2 steps. Makes that one wrong? Makes that one wrong. And it says, now you also have to know of the 2 one-steppers, which one's exothermic? 3. So 3. This one would be the answer to the question, which of the following represents the course of an endothermic SN2? That'd be this one, right? I can make any of these 4 answers right. This is an exothermic SN1. Here. Exo SN1. Endo XN1. Overall, ends higher than it started, right? Overall, ends lower than it started. And this is the correct answer, and this would be endo SN2. There's your only 4 diagrams. So maybe I'll just pick another one of the 3. What do you think?
Yeah, are you gonna leave it like SN1 or SN2, right?
I'll make one of the other 3. One that's not answer C. Then I'll change the order, so it might still be answer C. There you go. There's only 4 possible questions here.
Okay.
That's all I'm saying. We got them all covered.
Yeah.
All right, there you go. I like it when we're designing our test together.
Yeah.